Okay, so your answers are we add and multiply decimals just the same way we do whole numbers, except that you have to keep track of where the decimal point goes, okay, which is correct. For the whole part, for the whole number part, the place value system is the same as the whole number place value for whole numbers, okay, which is correct. Decimals are better than fractions when I need to do a lot of calculations, which is true, because the advantages in using decimals is comparable to fractions. If you're given fractions, say a big large fraction like this, you will take a lot of time to decide which is greater and by how much, okay. But if you're given the same thing in decimal, you can compare it easily, as shown in this example here. Very easy to compute, like addition, subtraction, all that very easy to do in decimals, because decimals follow the same place value as the whole number system. For fractions, of course, computing this is very much more difficult, because you need to find the equivalent fractions first. That is why whenever children are given fractions, they try to always convert it to decimals, which is not a good idea, because they must learn how to do this by itself also lah. They must understand fraction magnitudes, not just convert it to decimal to understand magnitudes. Okay, and then we know that that we can easily compare decimals. Okay, and the same thing. So for fractions, you need to convert, find the denominators first. Equal denominators first. Decimals can convert easily into percentages, which is true. Easier to type in electronic application, which is true. Decimals very easy for us to type. Fraction need to use the equation editor. Okay. In designing calculators, computer languages, and even computers, we have chosen decimals over fractions. Okay. Decimals are fractions too, written another way, and the denominator is a compulsory power of 10. Okay, so the form makes decimal maths easily identical to the form of integer maths. Okay, and then finally we have decimals are easier to calculate. Okay, so this is subtraction of decimal, much easier to calculate compared to fractions. Decimals are easier to understand. For example, when we pay for something in the market, the cashier will tell us the total price in decimals, as it is easier to understand as compared to in fractions. Okay, so all of you have given some very good answers here. Okay, which you can run through later. I didn't take all because some were similar. So whatever was a little bit difficult, only I compiled it together. Okay. Okay, so you can read this later. So the next thing that the second question was what are some models for representing decimals? So you have written here, using decimal extends the place value system, grids, base 10 blocks, linear arithmetic blocks, number expanders, measurement models, okay, number line, precision ruler, decimal dominoes, these are for games, decimal dice, number lines, decimal tiles, money, yeah, money is very good, area and grid model. Okay, the others are almost similar, okay, and also here, models for decimals, number lines, grid models, base 10 blocks, again linear arithmetic blocks, number expanders, and then we have decimal cards and puzzles. All this will be like for activities. Area models, number line, number discs, not sure what is that, abacus, yes, abacus, decimal abacus, and then you have paper folding, paper strips, decimal circles. Okay, decimal models, tens and hundreds. These are squares and strips. Okay, the rest is more or less the same. Okay, so they're quite, Yun Jun has explained quite clearly here. Okay, just if you have the time, go and read this. Okay, So that is it. So you already have an idea of decimal models. Okay, so with that, we're going to continue with today's class. Okay. Okay, so today we're going to continue with teaching of decimals. We're going to look at the meanings of decimals, instructional strategies for teaching decimals, that means how to teach decimals, how to develop the concept of decimals, reading and writing decimals, equivalence of decimals, comparing decimals, addition, subtraction, multiplication and division of decimals, and models of teaching decimals. And at the end, we'll come to the models of teaching decimals. Okay, so we're going to look at all these things very quickly. Okay, the first thing that we're going to look at is the meaning of decimals. Okay, decimals. We know that decimals are special fractions, correct? Decimals are special fractions. They are known as decimal fractions. Okay, fractions such as any fraction that has a 1/10, 3/10, okay, 9/10, or 2/100, okay, 10 or 11/100. These are all special fractions because they are, if you look at their denominators, they're all in multiples of 10. Okay, 1/10 can be written as 0.1, 3/10, 0.3, 9/10, 0.9, 2/100, 0.02, 0.11. Okay, they're easily converted to they are easily converted to decimals. And the way we read these fractions, the proper way of reading this fraction is 1/10. Okay, and the proper way of reading this decimal number is 1/10 also. This decimal number, the proper way of reading it is 3/10, which is the same as reading the fraction. Similarly, for 9/10 is the same as reading this 9/10. We always read it as 0.9. That is actually the informal way of reading this. The formal way of reading this is 9/10. Okay, THS, 9/10. And it is the same for fractions also. Here we say this as 11/100. TTHS. We have the THS for fractions and for decimals. And this number is also read as 11/100. Okay. So if we teach the children to read decimal numbers and fractions in this way, this format, then they will understand clearly that decimal numbers and fractions actually name the same value. The numbers are the same, just that they are written in different formats. Okay, but they actually mean the same and the values are the same. Okay, so that is why it's important to teach them to read in the proper way. Okay, so when you have a number like this, 32.012, okay, this is a decimal number. We already know this, okay, and this is the whole number part, and this is the decimal fraction part. We call this the decimal fraction part, okay, decimal fraction, and this is the whole number part. Okay, so this is the first thing that we need the students to understand. What are decimal numbers? How are they connected to fractions? Okay, because when we teach we always teach fractions first in school. We always teach fractions first, and after they have learned fractions only, they can move on to decimals, because decimals and fractions are related. Okay. Okay, so when we want to teach decimals, we use two concepts that we want to base it on. Okay, the first concept is we want to teach. When we teach, we want to build on the place value knowledge. We know that students have already learned place value knowledge when they learn whole numbers. Okay, so decimal can be seen as an extension of whole numbers. So we are going to build on the place value knowledge. Okay, this part they have already learned. So now we are going to introduce the right hand side, the decimal part. Okay, so when we introduce this, we need to show them the relationship between numbers. From ones to tens, this is 10 times. Okay, this is 10 times. From tens to hundreds is 10 times. That means 100 is 10 tens and 110 is 10 ones. Okay, so when you go this way, you multiply by 10, but when you come this way, okay, you're going to divide by 10. Okay, so 100 is 1, oh sorry, 110 is 1/10 of hundreds. 1 is 1/10 of tens. Okay, so that relationship has to be taught. So when they come to decimals, they know that when they go this way, the number becomes smaller. So 1/10 is 10 times of 100s, correct? And 100 is 1/10 of tens. Okay, 1000 is 1/10 of hundreds. 110,000 is 1/10 of 10,000. Okay, and 110 is actually 10 times of 100s, and 100s is 10 times of 1,000s. So students should know this relationship. Okay, so because we're building on the place value knowledge. Okay, so when we build on the place value knowledge, we also need to use concrete manipulatives to help them understand. Okay, previously when we taught whole numbers, this was one unit, this was 10. Okay, and this was 100, and this represented 1,000. Okay, so this was 1 unit or ones. Okay, and this was tens, 110, 100, and 1,000. Okay, but when we teach decimals, we're going to use it the other way around. So before you start using base 10 blocks with children, we need to tell them, they need to understand exactly what it represents. Okay, so for decimals, now this will represent, we can use this as ones. Okay, ones, and this will represent our hundreds here will represent tens, TNTHS, tens. This will represent hundreds, and this ones here will represent thousands. Okay, DTHS. Okay, so for decimal numbers, we're going to use it the other way around. Okay, as it goes smaller, the value of the number becomes smaller. Okay, so supposing we put this here 1 to represent 1. So this, okay, okay, so this will represent the number. All right, sorry, 1.111. Okay, so this will represent the number 1.111. So we have 1 1/10s, 100s, and 1,000s. Okay, and here we have to teach them the additive and multiplicative quality. Okay, additive means Okay, additive quality, yeah. Okay. An example of additive quality is 0.45. It actually means 0.4 plus 0.05. So we have 4 tenths plus 5 hundredths. Okay, so children must understand this. Okay, these are the tenths place value and the hundredths place value. And the other thing that they must know is the multiplicative quality. Okay, multiplicative quality, for example, multiplicative quality will be like if there's a number 552.69, this number actually means that we have 400s, so it is 4 times 100, and we have 5 tenths, 2 ones, okay? And we have 6 of 0.1 plus 9 of 0.01. Okay, so students must be able to understand that this is what it means. Okay, and this we can teach them using the place value chart. Okay, so when we're teaching decimals, when we're relating it to place value, we have to use the place value chart and also use concrete manipulatives for them to understand the meaning of decimal numbers. Okay, and after using concrete manipulatives, or if there is no concrete manipulatives, then you can use if you don't if there is no base 10 blocks. Okay, base 10 block is a very good manipulative to use for teaching decimals, and that is the first choice that we should go for when we're teaching decimals. But if there's no base 10 blocks, then we can use something that is called, this is actually called a chip abacus. Okay, we also have concrete abacus, decimal abacus, but in case you don't have a concrete decimal abacus, also you can use a chip abacus. A chip abacus is all you have to do, you just have to draw this out on a cardboard or on a piece of paper. Okay, you draw the poles. Okay, you draw the poles, and then these are chips. Okay, you can use any colored chips, okay, or bottle covers or anything. Okay, and they just arrange it along the poles. Each pole has already been labeled, like this is the ones pole, is units or ones. Okay, from here we have the decimal numbers, so decimal numbers is starting from here onwards. Okay, so from here they can learn how to represent decimal numbers to understand the meaning of decimal numbers. Okay, so this is using the place value concept. Okay, so when you teach, the other way to teach is to build on fraction knowledge, because we know that students already have learned fractions. Okay, we know they've already learned fractions, so they understand fractions, so we can use that knowledge to help them to understand decimals. Okay, so how can we do this? Okay, just we look at one example first. So if we have a number here like this, say we're doing this in class. Okay, so we're teaching this 0.3 multiplied by 0.7. The usual method is to just teach it like this. Okay, standard return algorithm. But usually when students do this, sometimes they make a mistake here. They put the decimal over here because they count here 1 2, like how they do for multiplication, and they put the decimal over here. So this kind of errors can occur when we do computation with decimals. The most number of errors usually happens for decimals, because children always get confused with where to put the decimal. So if we taught this same example using fraction knowledge, Okay, if we want to teach the same thing using fraction knowledge, we would probably teach it like this. So we know that 0.3 times multiplied by 0.7, we know that 0.3 is actually 3 tenths. 3 tenths times 7 tenths. Okay, so 3 times 3 tenths times 7 tenths is 21 over 100. So this is 21 hundredths. 21 hundredths is 0.21. So when students do it this way, they understand why the decimal is after two places. Okay, they understand because it's 10 times 10, so it becomes 100, and 100 means two decimal places. So next time when they do 0.3 times 0.7, they know where to put the decimal immediately. Okay, so here we are teaching them based on fraction knowledge. Okay, so these are the two ways of teaching decimals. One is based on place value knowledge, and the other is to teach based using fraction knowledge. Okay, so we're going to continue looking at meanings of decimals. Okay, so just now we when we were teaching meaning of decimals, we used a place value chart, and we used base 10 blocks and also a chip abacus. Okay, so after we finish that, you know, we always teach according to concrete, pictorial, abstract. So we use concrete and then we move on to pictorials. So these are known as, you can call them square grids. Okay, you can call them 100 squares. Okay, something like anything. So the normal ones use square grids, and these are 10th strips. Okay, 10th strips. So normally this we use to teach tenths, and this is used to teach hundreds. So we normally use this to ask them to represent fractions. So for them to understand the meaning of fractions, say we want them to represent one, because children always get confused over these two numbers. Okay, so we want them to represent 1.40 or 1 and 40 hundredths, and the second number is 1 and 4 hundredths. Okay, if you teach them to say it properly, they can understand the difference. But if we just look at it at 1.40 and 1.04, it's a little bit difficult. Okay, so if we wanted to represent 1.40, so we would represent 1 first. Okay, so we're going to color everything here. Okay, this is 1 and 40. So if we read it as 1 and 40 hundredths, so that means we have 1 and we need another 40. So we are going to color 40. So this is our 1.40, and then we have 1 and 4 hundredths. So we color our 1 first. Okay. And then we have 4 hundredths only. That means 4 out of 100. Okay, so this is 4 hundredths. Okay, so when children represent numbers like this using decimal squares and decimal strips, they understand the magnitude of decimal numbers. We are not just comparing, we are actually looking at magnitude of decimal numbers. And another one is they also need to know that 0.3 is the same as 0.30. Okay, this is 3 tenths, 3 tenths, and this is 30 hundredths. Okay, they need to understand that these two numbers are the same. Okay, so how are we going to help them to understand that the two numbers are the same? By using square grids and strips. Okay, so 0.3 will be 0.1, 0.2, 0.3. 30 hundredths will be, this is 10 hundredths, 20 hundredths, and 30 hundredths. So when children compare these two, they see that the colored area is exactly the same. So they know that this value and this value is actually the same. Okay, because many children think that 0.30 is a larger number compared to 0.3, because 30 is so much bigger than 3. Okay, so this must be taught clearly. Okay, this is all part of meanings of decimals. Okay, so when we teach meanings of decimals, we use concrete manipulatives like base 10 blocks, chipped abacus, tenth strips. Tenth strips are to teach tenths, and square grids are to teach hundreds. Okay, and the other thing that we need to teach children is what does 1/1000 mean? What does 1/1000 mean? Okay, 1/1000, 1/100s, children can understand when you show them the square grid, but 1/1000 is difficult for them to visualize. Okay, so we need to use this thousandth grid to help them to visualize this. Okay. Okay, this is a thousandth grid. Okay, so you tell me. Okay. Okay, what fraction is represented by that one small section? Okay, let's go the other way. Okay, this whole thing, how much is this whole thing? Anyone?
10.
10? What number is it represent? You can tell me in fraction or in decimal. Did you say it is this tenth? 1/10? Is this 1/10?
100th.
Yes, 100ths. This is 100ths. If it's difficult for them to come up with this, maybe the best thing is to shade all this first. Okay, this whole row. Okay, so if you shaded this whole row, okay, then you can ask them, okay, how many strips like this are there here? So you can see that there are 10. So each row now represents 1/10. Each whole row represents 1/10. So if one whole row represents 1/10, how much is this whole? It's just one box. And we know that one box of this is out of 10 boxes. So this one green box represents 1/100. Okay. If that one green box represents 1/100, what does this one small box represent? So that will be, it is actually 1/10 of 100. This is actually 1/10 of 100, which is 1/1000. Okay, so we need to highlight sections and ask them to be able to tell you the numbers. Okay, children need to be able to see this 1000 grid and understand that each small section is 1000. Okay, and they need to practice using this to label decimals. Okay, this is a very important teaching aid to help them. But normally we stop at square grids, at hundreds. Okay, we should do this until here, 1,000. Okay, but because a lot of children, they're not exposed to this, so they cannot visualize what is 1 over 100. They cannot visualize how small is this compared to 1 over 100 and 1 over 10. Okay. Okay, so next we're going to look at okay. So let's look how we can develop this further, develop the concept of decimals further. Okay. Okay, to develop the concept of decimals further, we are going to use number lines. Okay, number lines are very, very necessary to teach decimals. Okay. Okay, so we start with the first type of number lines, 0 and 1. Okay, so from here, they are going to learn tens. Okay, they're going to learn tens with this kind of number line. Okay, so they need to know this is 0 0.1, 0 0.2, 0 0.1 means from here to here is 0 0.1 until they reach 1. Okay, we can also use a meter ruler. This is 1 meter. Okay, if we say this is 1 meter, so how much is 0 0.1 meter? So they should know that 0 0.1 meters up till here. Or how much is 20 centimeters? Okay, 20 centimeters is 0 0.2 meters. So 0 0.2 meters. Okay, and then we use the second number line for hundreds. Hundreds because each part is divided into another 10 parts. So we can ask them to label, read and write decimal numbers based on this. We want them to read and represent decimal numbers, okay? So we're teaching them to represent decimal numbers. These number lines will be suitable for hundreds, okay? Number lines must be done for decimals, and then later you want to introduce them to uh, whole numbers and decimal fractions, like say 3.4, okay, 7.5 or 7.6. Okay, you can move on to this kind. So there should be a gradual movement from tens to hundreds and then to mixed decimals. Okay, so uh, using using number lines to teach decimals is a very important conceptual development. Okay, must be taught in class. And then later you can give them activities like this. This is a very I found that this is a very good activity. Okay, so like this, like you see, look at A is given here. This is 6 and 400ths. 6 and 400ths. Okay, this is A here, A. So when you look at this decimal line, you know that this number here is 6 and the number at the end here is 7. 6 and 7. And in between, you can see 6.10. So there are 10 sections here. That means altogether there are 100 sections here. So that means we're looking at hundreds. Okay, so they must be able to identify this. How many sections are there? Is the number line divided into, and does it represent tens or hundreds? Okay, so we can see here that A is actually 6.01234. So A is 6.04. Okay, another way of writing that is 6 and 400ths. So this is in decimal and this is in fraction. Okay, so we're connecting decimals and fractions. Okay, so B will be 6.08, 6.08, which is 6/8 over hundreds. Okay, how we read the number? Both the number are read the same way, 6 and 8 hundredths, and fraction also 6 and 8 hundredths, THS. Okay, so children can practice reading of the numbers in decimals and in fractions. Okay, you can give them some in fractions, some in decimals. Okay, so this is a very good activity to convert from fractions to decimals and decimals to fractions, vice versa, and also to represent fractions and also to read fractions from to read decimals from number lines. Okay. Okay, next we go on to reading and writing decimals. Okay, once they know how to represent decimals using concrete materials and area models and pictures, square grids and tenth strips, then we can reinforce reading and writing decimals. Okay, so this will also be a very good aid. This chip abacus is also a very good teaching aid to teach children to read and write decimals. Children can work in pairs. One child can actually represent the decimal numbers, and the other child can read out the decimal number. They can take turns to do that. Okay, so when they have mastered that, then they could move on to this chart where you could actually give them a sample number. Okay, where you can give them a number, say 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 okay, so you give them the number, they write it in words here. So this will be 32 and 835 hundredths. Okay, and then maybe you give another number here, 4 and 45 hundredths. Okay, 4 and 45 hundredths. So children must be able to write 4 and 45 hundredths. That means it must reach until here. Sorry, this is thousand, until here, 45 hundredths. Okay, so like this, or you give them a number, they must be able to read and write. And the other thing that they must be able to do after they read and write decimal numbers is they must be able to expand decimal numbers. Okay, for example, 32.835, students must be able to write this as 32 plus 0.8 or 8 tenths plus 3 hundredths plus 5 thousandths. Okay, so this actually means 32 plus 8 tenths plus 3 hundredths plus 5 thousandths. Okay, and this can be written as 32 plus 835 thousandths. Okay, which is actually 32,825 over 1000. They must know how to expand the decimal numbers to show that these two actually means the same. Okay, so all this is very important when you teach them. So when you teach in class, they must be given activities to do all these kind of things, not just focusing on the algorithm only. Okay, so we have looked at that. Now we're going to move on to equivalence of fractions. Equivalence of decimals. Okay, like we did this just now, a concept of equivalence. Children must know that 0.8 is actually the same as 0.80. How the best way to do this is to use fraction strips and square grids to show them that it actually means the same. Okay, so we can do this for bigger numbers, different numbers, okay, any decimal numbers, until they understand the concept of equivalence. And after we teach them the concept of equivalence, we have to teach them comparing decimals. Okay, to compare decimals, because children, they always have a bit of problem when it comes to comparing decimals. Of course, to compare decimals, we start using base 10 blocks or any other concrete material. For example, 1.32 represent 1.32 using a place value chart. Okay, and then represent the second number also on the same place value chart. And then when you compare decimals, we always compare from left to right. Okay, same. So this is same. And then we look at the next number, which is the tenths value, and we can see clearly that this number is bigger. There's more tenths compared to the first number. So 6 tenths is more than 3 tenths. Therefore, 1.6 is greater than 1.32. Okay, so we need to represent the numbers concretely and then teach them to compare from left to right. Okay, because most children will tell you that this number is bigger than 1.6 because the number is longer. There are more digits behind the decimal point. Okay, and after we use that to compare, we use square grids to compare, like how we did earlier. Okay, so you want to compare 1.65 and 1.5, 1.5, same thing like how we did earlier. Use your square grids, and then color them and use 1.65 will be 1.5 until here, 1.5, 1.6, 1.65. Okay, so all this we are going to color all this here. Okay, and then 1.5 will be all this and 5 of this. Okay, so they can see which number is bigger straight away. Okay. Okay, so that is comparing fractions. Comparing fractions need to be taught using manipulatives, concrete and visual, before we teach them rules, compare from the left to right. Okay, so after we've taught them comparing fractions, then we move on to computation, addition, subtraction, multiplication, and division. Okay, so we start with addition and subtraction. Okay. Okay, so addition and subtraction, like how we saw earlier, usually there are a lot of misconceptions here. Sorry. Say we have an example here, 23.6 plus 1.73, okay, and the answer is 409. So the misconception here is a lot of children will put the decimal point here because it's 1, 2, 3. They use the same principle as in multiplication rule. Okay, so that's why this, when you teach this, you need to teach it connected with fractions, and also you need to, if when you're teaching the algorithm, you need to emphasize on these three things. Okay, that they need to line up the decimal points or align the decimal points. They need to use zeros as placeholders, and any whole number added to a decimal number, the whole number must be written as a decimal, in decimal form. Okay, for example, look at the first example, 0.6 plus 0.25. Okay, this is teaching them addition using a model here. Okay, this is a square grid here, so we have 0.6 plus 0.6, 0.25. So because this is a 100th decimal, we need to change this also to a 100th decimal. Okay, so when you do the algorithm, 0.6 plus 0.25, then this we must add a 0 here as a placeholder to show them that these two are the same types of fractions. Both are 100th fractions, so it's easier to add. Okay, so 6 tenths is also equivalent to 60 hundredths plus 25 hundredths, so you have 85 hundredths. Okay, so So this we are teaching them addition of decimals using models. Okay, next, let's look at the next example here. We have 0.32. Okay, example 1. So we have 0.32. Okay, plus 12.965 plus 1.1. We can see that the number of decimal uh, the number of digits behind the decimal points are all different. We have 1, 2, and 3. So when we want to teach them to answer this question, a good method will be to make it all the same. Okay, so we need to add zeros as placeholder. So this will be 0.320 plus 12.965 plus 1.100. And then only use the algorithm, align all the decimal spaces, and we add. Okay, so our zeros here are acting as placeholders. Okay, and then they can add as usual as they add whole numbers. Okay, so if the students remember this, first to align the decimal points and then to add zero as placeholders, then they won't go wrong. Okay, adding zero as placeholders is also very important for subtraction, so that they can subtract easily without making any mistakes. Okay, so the second example here is 51 plus 14.02 plus 2.1. So here also we want them to rewrite these numbers as this is a whole number. We want them to rewrite this whole number as a decimal number. We can see that there are two decimal places in this number here. So we make it on to two decimal places, 51.00 plus 14.02 plus 2.10, and then only change it into standard written algorithm, and they can edit. Okay, so this is to avoid misconceptions when they find the answer. Okay, we need to tell them so that it'll be easier for them to align the decimal points. Similarly for subtraction, if you have 12 minus 8.13, we change this to 12.00. We encourage them to write it in this way first before they write it in standard written method. So we want them to write the 00 here so that they know that when they subtract this, they need to borrow from 2. Okay, so we have 10 here. They need to borrow and do this. Okay, if they don't write the 00, we're afraid that they must just write 1, 3 here. Okay, so when they put the 00, they will remember to borrow from the 2 before they subtract. Okay, so when we teach addition and subtraction, we need to stress on some rules. But before we tell them these 3 rules here, okay, before we tell them these 3 rules here, we need to show them how to do addition and subtraction using models. Okay, so because when they use the models, they relate to the rules. Okay, they know that they have to convert the numbers and add zeros as placeholders. Okay, so that is for addition and subtraction. Next, we're going to look at multiplication. Okay, multiplication of whole numbers, decimal numbers. So the first example is whole number times decimal number, which is 2 times 1.3. Whole number times the decimal number. As you have seen for whole numbers, whenever you do multiplication, you try to form a rectangle, because multiplication of two numbers, the answer or the product is equal to the area of a rectangle with dimension 2 and dimension 1.3. Okay, 2 times 1.3. Multiplication always refers to the area. So whenever we do multiplication, whether it's fraction or decimal or whole number, we try to form the rectangle. One side is represents one number and the other side represents this one number. Okay, so here we have 1 plus 1/10, 2/10, 3/10. So this is 0.3 and here's 1. Here we have 1 and 1. We form the rectangle and then we can find the answer. So this is 1, 1, and we have 6/10 here. So this is 1 plus 1 plus 6/10 or 0.6. So this is 2.6. Okay. The second example here, 4 times 0.07, also whole number times a decimal number. So when we have 4 times, we know that 4 times 0.07 is actually 0.07 plus 0.07 plus 0.07 plus 0.07. We have 4 groups of 0.07, okay? 0.07 is 7/100. So we are going to use a square grid here and we want to show 4 groups of 0.07. So we have one group in yellow, then we have another group in blue, another group in yellow, and another group in blue. So we have 4 groups. From here, we can see that this is 28, 28/100, okay? 28/100 or 0.28. Okay. Similarly, for this example, 3 times 0.3. Whole number times a decimal number. 3 times 0.3 is 3 groups of 3/10. Okay, 3 groups of 3/10. So we ask them to shade one group of 3/10 first, and then second group of 3/10, and third group of 3/10. And we can see clearly here that we have 90/100 or 0.90. Okay, it is good for them to see this connection here like this. Okay, so this is multiplication of whole number and decimal. Then we can move on to multiplication of two decimal numbers. Okay, this is multiplication of two decimal numbers. Okay. Okay, multiplication of two decimal numbers. So the first one, 0.3 times 0.2. Okay, so these are tens actually. So we should represent 0.3. This is actually tenth strip because we are using a 100 square because the multiplication product will be in hundreds. Okay, so we are actually using represent this as 1/10, 2/10, 3/10. Okay, and then the other way horizontally we are going to represent 1/10, 2/10. Okay, so this is 0.2 and here is 0.3. So 0.2 times 0.3 is this rectangle, which is 0.2, and over here is 0.3. Okay, so we have 1, 2, 3, 4, 5, 6/100. Now this 6 is out of 100, so it is 0.06. Similarly, for second example, 0.1 represents 0.1, 0.7 shade 0.7 the other way around. So the place where it intersects, this one is 0.7, this dimension is 0.1. So the area, the green area represents the area 0.1 times 0.7, which is 7 boxes out of 100 boxes. So the answer is 0.07. Okay, so when we are teaching multiplication of decimal numbers in tens, then this is a very good teaching aid to use. Let them understand this first before they move on to the algorithm. Okay, so we connect this with the algorithm. Okay, and then when we are teaching decimal numbers that also involves whole numbers, three like this. Okay. Okay. 3.5 multiplied by, this is 3.5 multiplied by 2.8. So this dimension here is 3.5. 1, 2, 3, and we have 1, 2, 3, 4, 5 tenths. So it's 3.5. Okay. So this dimension on this side, here is 2.8. 1, 2. So we have 1 8, sorry, 1 10, 2 10, 3 10, 4 10, 5, 6, 7, 8 tenths. So this is 2.8. Okay. So once we have established both dimensions, then we fill it up. We add all the other parts until it forms a rectangle. Okay. So it must form a perfect rectangle. Then we can read off our answer. So this will be 1, 2, 3, 4, 5, 6. Okay. So 3.5 times 2.8. We have 6 here. Here is 1, 2, 3, 4, 5. We have 10 tenths. Okay. And here we have 0. We have 0.8. Okay. 0. Sorry, 0.18 times 2 times 3 is we have 24 tenths, correct? 24 tenths. So we have 24 tenths here and we have 10 tenths here. Okay. And over here we have 40. 40 hundredths. We have 40 hundredths. So what is this? 40 hundredths is 0.40. 10 tenths is 0.10, correct? What is 10 tenths, class? It's 1, 1 tenth, and so this is 1, okay? So this is 1.0, and this is 24 tenths will be 2.4, correct? 2.4. Okay, so when we do this multiplication, we have 5 times 8 will be 5 times 8. 0.5 times 0.8 will be 40, 0.40. And then 3.0 times 0.8. 3 times 0.8 will be, what is 3.0.8?
2.4.
2.40. Okay, so this is 2.40, and then we have 0.5 times 2. So we have 1.0, and then we have 3.0 times 2.0 is 6.0. All right, 6. So we have 0, 8, 9.80. Do we have 9.80 from our diagram? Yes. Where is this 0.40 coming from? This is here. Okay. 2.4 is from here. 1.0 is from here. And 6 is from here. Okay. So when we are doing multiplication of whole number with decimal fractions like this, okay, this is a good method to use. At first, when we're doing this, we just do the concrete version only, okay? We don't have to do the algorithm. When they have mastered this, then we have to do the algorithm and show how it translates from the concrete or conceptual multiplication to procedural multiplication, okay? This is an algorithm. What is the name of this algorithm? Anyone? When you do it like this, what is the name of this algorithm? You can also do it 3.5 times 2.8. Okay, 8 times 5, 40, 0, 4. 3 times 8, 24, 28. 5 times 2, 10, 0, 1. 3 times 2, 6, and 7. So 9.8, 0, 1, 2 point here. Okay, what is the name of this second algorithm? We call this
Standard algorithm.
standard return algorithm, okay? We must teach this, okay? But we will teach this only at the end. We do this first, okay? Followed by this, and then last only we do the standard return algorithm. What is the second algorithm here called? What is the second algorithm here called? Anybody? It's very important for you to know this name, okay? Partial product. We have done this already when we did whole numbers, partial products algorithm. Okay, when you break it up, because we're doing partial algorithm, first we're doing the 0.5 times 0.8, and then we're doing 0.5 times 2, and then we're doing, first we're doing 0.5 times 0.8, and then 3 times 0.8, and then 0.5 times 2. Okay, so this is actually what? Okay, this is actually 0.5 times 0.8, okay? Second step here will be 3.0 times 0.8. The third step will be 0.5 times 2. Here will be 3.0 times 2.0. So we are doing partial multiplication. That's why it's called partial products algorithm. We are doing part by part. Okay, this is partial products algorithm. We can also do this for fractions and for whole numbers. Okay, this algorithm is very good for us to teach this algorithm because it relates directly to this diagram here. Okay, the standard written algorithm doesn't relate directly. Okay, so when the children see that it relates directly, they understand why you need to build the rectangle like this and get the answer. Okay, and then from here, partial products algorithm, you relate it to the standard written algorithm. Okay, where did this come from and where did this come from? Okay, we relate it. So that is how we teach especially multiplication. Okay, from the concrete pictorial. Concrete means we can build this whole thing using paste and blocks, or we can use an area model to draw this, then it becomes pictorial. And then we translate this to partial products algorithm. From partial products algorithm, we translate this to standard written algorithm. Can you understand that?
Yes.
Okay, why I'm
Yes.
spending so much of time on this is because it's important, okay? So it is the same method, whether you use whole numbers or decimals or fractions. Whenever you're teaching multiplication, we start with the rectangle first, okay? Until they have mastered the rectangle already, the rectangle can be concrete or in pictorial form, okay? If you're using the CPA method, you will start with concrete, and then you will do the pictorial, and then abstract is algorithm. Okay, when you do algorithm, you do the partial products first because you want to translate from the diagram to the algorithm. once they understand the partial products, you must show which part is for which part, okay? And then exactly like how we did here, draw the arrows. And then you transfer it to the standard return algorithm, okay? Okay, so now we're going to look at division. Division also can be taught using teaching aids. Okay, so here we're using base 10 blocks. Okay, when you use the area model, it will also be the same. Okay, so for division, say you have 3.4 divided by 0.4. Okay, so you have 3.4 divided by 0.4. For children, when they look at this, it's so abstract. They don't know what it means. Okay, they don't know what this means. So for division, the question that you must always ask is how many 0.4s are there in 3.4? The same thing we did for fraction. Say fraction whole number divided by 2 half. We asked how many halves are there in 3. So for division, we always ask how many of the divisors in the dividend, okay? How many 0.4s are there in 3.4? If you ask this question, then it's easy for them to answer because all they need to do is represent 3.4. So here we represent 3.4. This is 1, 2, 3, and we have 0.4. Okay, you can draw out the whole thing actually and just shade this part 0.4. Okay, so we have 3.4. Now we want to know how many 0.4s, which are 4 tenths, or 4 tenths are also equal to 40 hundredths. So we want to know how many 0.4s are there in this. So what is the answer here? So we know that this is 0.4. Okay, this is 0.4. This, okay. Okay. So there is 0.4 here. Okay. And then there's another 0.4, and then we have one more 0.4 plus 2 here. Okay, 0.4, and then we have another 0.4, and we have another 0.4 here. Okay, same thing here. Okay, until here we have 0.4, and then another 0.4 here, this 2 plus this 2. So how many 0.4s do we have? So how many? Did I do it rightly?
5, maybe?
How many?
5.
5. So 3.4 is 3 and 4 tenths divided by 4 tenths, correct? Is this correct?
Yes.
34 tenths times by 10 over 4. That is 34 over 10. I'm doing this wrongly. Sorry.
Seven point two.
734 divided by 4 is 2 and 17 over 2, correct? So this is 8.5. Am I right? 8.5.
Yes, madam.
Now, 1, 2. So these two will be 3, 4, 5, 6, 7, 8, and here we have half of 0.4. So this is a half. So the answer is 8.5. Okay, so this is how we teach division. Okay, we just need to represent the first number and then ask how many. So if you have a number like 5.3 divided by 0.2, so all you need to ask is how many 0.2s are in 5.3. So we represent 5.3 and then divide it or section it off into 0.2s and count how many we have there. Okay, so that is teaching division using teaching aids. And then later we need to teach them the algorithm. Okay, so when we teach them the algorithm, say we have a number here like 6.85 divided by 0.5. Okay, so we need to teach them to remove the decimal point from the divisor. So if you're going to move this one, you need to move this here. So 68.5 divided by 5. Okay, they need to understand that this two is the same. Okay, after this they can use normal long division, or another way you can straight away move two decimal places. So if you don't want to deal with decimals, so 685 divided by 50. All these two are the same. All these sentences are the same. They must understand that lah. So if we teach them using area model or base 10 blocks, they will understand what this means. So they won't be so afraid of this anymore. Okay, so it is not so abstract to them anymore. Okay, so that is division. And finally, we're going to look at models for teaching decimal. We have already used a lot of models. So we're going to look at the models. Okay. First model. You're already familiar with this, base 10 blocks. Okay. Second thing that we are going to use are tens grid or tens strips. Okay, this is to teach tens. Okay, square grids to teach hundreds. Okay, so these are how we normally use them. This is also used for fractions. Okay, so we're using the same thing that we use for fractions, just that we're using in a different way. Okay, and then for decimals, we also use number lines. Tens number line, whether it's tens or hundreds or thousands, depends on the number here. Okay, and how many sections or partitions we have here. Okay, number lines are very, very important for, especially for decimals. And then we can use money. Money, I think we can use it in the normal way. Okay, because money is already in decimal, like this. That this first diagram here, it would represent 5 point, we know this is 50, 60, 70, 85, 5.85. Okay, the second diagram here will represent 0.80. Okay, so it's 80 cents, because money is already in decimal form. Okay, all children already know this, so it is a good model to use because children are familiar with money in daily life, so they can easily translate it to decimals. The other thing that we are going to use here is a ruler, a meter ruler. Okay, a meter ruler. A meter ruler because there's 100 sections in a meter ruler. Okay, 1 to 100. So it's easy to teach decimals. Okay. This is also very important to teach them how to read decimals from a meter ruler. Okay. Okay, and then the other thing that we use is this. This is called a beads string. Beads string. And a bead string, usually it comes like, usually we use like in two colors. Okay, so like this is 10, this is another 10. So this is 10, 20, 30, 40, 50, 60, 70, 90, 100. Okay, so this is a 100 beads string. So we can put out the beads in a row, and then we can ask them to identify where is 0.4 and where is 0.50 and so on. Okay, until hundreds we can use to teach this. It's also very useful to teach decimals, also can be used for fractions. Okay, anything that you use for decimals you can also use to teach fractions. And this is called a decimal abacus. I think you have seen this. We have this in most schools also we have this. So just like a abacus that we use for whole numbers, here they've extended it for decimals. Okay, so they can read the number straight away. If you don't have a decimal abacus, you can use a chip abacus. A chip abacus is also very nice to use. This is you can use it on paper. You just have to draw out the frame on the paper. This is the frame. Okay, draw out the frame, label the frame, and then use chips here to represent. These are non-proportional models, okay, because the size of 1 and the size of the tens are the same. Okay, so therefore these are non-proportional models. The base 10 block is proportional model. Okay, that's it. So these are some of the models that we can use to teach decimals. Of course, this number one choice will be base 10 blocks, and this will be number two choice. Base 10 blocks is concrete, square grids and tens strips are visual, pictorial. Okay. So if you're using the CPA method, if you still remember, the C stands for concrete, P is for pictorial, and A is for abstract. Concrete manipulatives, you teach them using things like base 10 block. After you teach using concrete, you move on to pictorials, area models and all that. And finally, you move to abstract. Abstract means anything that is written in black and white, in symbols and language and numbers. That is abstract. So all algorithms are abstract. Abstract is very difficult for children. That's why we always start from concrete, pictorial, and last only we teach them abstract.